Get it out. Here we go. This gives you a good idea of some of the Physics 12e stuff that you can see on your test. Number 1 says, suppose this mass begins from rest. I think that's a key word. If m1 equals 2.8 kilograms and mu equals 0.12 and the angle of inclination is 52 degrees, find the time it would take for this mass to slide down a distance of 6 meters down the slope. So I said, okay. I did that. I said, well, I know that's not enough to find t. Aha! I said. If I find the acceleration using winner minus loser and all that stuff, then I think I can put the acceleration there and solve. By the way, is this mass speeding up or slowing down? Read the question carefully and figure it out as it slides down the hill. Is it speeding up or slowing down? How do you know it's speeding up? Because what's its initial speed? Okay, what would I make sure I did if it was slowing down? If it was slowing down, I'd probably put a negative there right now just to remind myself, hey, in Unit 1, we did have to get fussy with the signs because we didn't have things moving in more than one direction at the same time like we do in Unit 2. But since it's speeding up, no big deal. All right, what are the forces acting on this block? I have good old mg. I have a normal force at an angle. Pretty sure I have friction. In fact, that would be my free body diagram if I asked you to draw it. Now I'm going to take gravity and I'm going to break it up into its components. I'm going to have mg perpendicular and mg parallel. All right. Graydon already said, hey, you're sliding down the hill, Mr. Dewick. So who's winning? My equation is going to look like this. mg parallel minus friction equals ma. By the way, what if this was sliding up the hill? Which way would friction be? Down. In fact, I wouldn't have any loser. It would be winner plus winner. It would be gravity plus friction, mg parallel plus friction, which is why if you try sliding something up a hill, it comes to a stop so quickly because there's two forces slowing it down. Right? Mg parallel. Oh, we have this wonderful two lines as sign that Cole gave us. What was the angle? I've scrolled down. 52 minus mu times the normal force. And if I divide everything by, not by A, Mr. Dewick, by M, I'm good to go. I don't know the normal force. Oh, but look. Dylan, I know another force the same size as the normal force, mg perpendicular. So really what I could have written right here instead of Fn, I could have written mg perpendicular, which, I think ends up being mg cos. And I'm running out of room. I normally wouldn't quite do all of this in one step on a quiz. I might try it in my homework, but on a quiz I'd show more work. But I'm running out of room. So it's going to be mg cos 52. That equals the acceleration. Yep.
If you did that equals ma, would the m's cancel out?
Heck yeah. I think, you know what? If I did that, Graydon, you get a candy, my friend. Graydon says, hey, yo, Mr. Dewick, if you did that equals to ma, yo, Schmarty Pants, the m's cancel out. I say, yes, they do. Silly me. So if I hear you correctly, Graydon, you're saying that the acceleration is going to be 9.8 sine 52 minus, what was mu? My default is usually 0.12. That seems to be my favorite one when I'm making stuff up. Times 9.8 cos 52. And I get an acceleration of 9.8 sine 52 minus 0.12 times 9.8 times cos 52. Do you get an acceleration of 6.998, 7.00? Okay, I'm going to keep 6.998 since I'm going to be using that. They didn't ask me to find the acceleration. They said find time. Okay, so now I know up here my acceleration is 6.998. I'm looking for an equation that has t, vi, d, and a in it. Hey, I'm pretty sure that's going to be d equals vit plus a half a t squared, where vi is 0. I think t ends up being 2 times d divided by a square rooted. I think t is going to be the square root of 2 times 6 divided by 6.998. I think it's going to be 2 times 6 divided by this previous answer, and then square root of that. Do y'all get a time of 1.31 seconds? Woohoo! If you got that right, that would give you 4 out of 4. Otherwise, in terms of part marks, I gave out... Come on, computer. Hello. Quiz 2 answers. I gave you 1 mark if I saw g sine 40 minus mu g cos 40 equals a. Wow, why do I have 5.4 here? This is the same one? 6. Oh, different angle. You know what? This is quiz version 2. No wonder I'm freaking out for a second there. Where's quiz 2 version 1? Quiz 2 version 1 answers. Let's try that again. How about, yeah, there you go. Looks like I gave a half mark if I saw that, a half mark for that, 1 mark for the acceleration, half mark if I saw d equals vit, half mark for that, and then 1 mark for the answer. But if you got the right answer, you get 4 out of 4. But if you're wondering if you got it wrong, where I'd give up part marks, probably something like that. And then we go to the next page. Find the acceleration if m1 equals 5.3 kilos and m2 equals 7.6 kilos. Okay. What are the forces acting? I have m1g, tension, m2g, tension. Who's winning? It's going to be m2g minus tension plus tension minus m1g equals m1 plus m2 times a. Do my masses cancel this time, Graydon? So no. Good. My tensions cancel, however. I have a latecomer. Let's see. Continuing on where we left off. Let's see. I think I'm going to get an acceleration that equals m2g minus m1g all over m1 plus m2. I'm going to get 7.6 times 9.8 minus 5.3 times 9.8 all over whatever 7.6 plus 5.3 is. 7.6 times 9.8 minus 5.3 times 9.8 divided by bracket 7.6 plus 5.3. You get 1.74728, 1.75 meters per second squared. Find the tension in the rope. I'll look at just one mass, and I'm going to be clever and pick the mass where tension is winning. So I'm going to look at mass 1. If I look at mass 1, I'll get tension minus m1g equals m1a. I'll get tension equals m1a plus m1g. It's going to be 5.3 times 1.75 plus 5.3 times 9.8. I'm going to get 5.3 times that acceleration plus 5.3 times 9.8. Whoop, times 98, Mr. Duke, times 9.8. And you get a tension of 61.2 newtons. Okay. In terms of marks, I think I did something like this. 1 mark for that, half mark, half mark. And I'd probably go 1 mark for that equation, a half mark, half mark. Most likely. And then I would turn the page. A student of mass big M places a bathroom scale on a skateboard. He then rolls forward on level ground while standing on the scale, which is still on top of the skateboard. What will the scale read? More than M, less than M, or just plain old M? I think. Because I think vertically there's no change in forces, yes? A student now rolls the skateboard down a ramp, which is inclined at an angle. Couldn't find the theta key, so I found a phi key on my Mac when I was typing this up years ago. While standing on a scale, which is still on top of a skateboard. Of course, the key idea here is what we're really saying is a scale measures the normal force. A scale reads the normal force. So what this question Zach is really asking you is, hey, what happens to the normal force? Well, I think at an angle less than M. Using principles of physics, explain your answer to be. I think I would say something like this. Scale measures normal force. You could probably draw a good free body diagram if you wanted to, but on a ramp, the normal force is equal to mg perpendicular, which is mg cos theta, which has to be smaller than mg because cos theta is a decimal. If you did something else, if you wrote something else and you think it's right, give yourself the marks. If you're not sure, show it to me later, and I will lawyer with you and probably give you the marks, but also give you some feedback if you want that. Pardon me?
Like one of those diagrams that you did in other lessons.
Like a free body diagram?
Yeah, like one, he's on top of the skateboard, and two, he's like falling just on his side, so therefore it must be less.
In fact, my friend, we have this. And I probably have to pause the video because I'll bet you this will show up on. Continue. I think I have one more question on here, don't I? Ah, yes. Assume no friction for the following question. Although I would say adding friction would not be unacceptable. There'd only be friction on the mass that's on the ramp anyways because the other one's hanging in midair. If M1 equals 10 and M2 equals 4 and the angle of inclination is 56 degrees, find the acceleration of the system. Now, if this is 10 kilos, and this is 4 kilos, I know the 10 has to be winning because the 4 is at an angle, which means it's not pulling straight down. Definitely the heavier mass is going to win. If they had flipped this, if they had the 4 sitting right here and the 10 sitting right here, I'd have to make a guess, and if I guessed, how would I know if I guessed wrong? Negative acceleration. I'd work my way through it somehow. Anyhow, I'm pretty sure that my winner is going to be M1G, and there's going to be tension. And there's going to be M2G, and there's going to be tension, and there's going to be friction, and there's going to be... Oh, frictionless, good gosh. And there's going to be M2G, the perpendicular component, and M2G, the parallel component. It says find the acceleration. Who's winning? M1G. So it's going to be winner minus loser. Oh, but then I run into tension plus winner. Oh, but then minus M2G parallel is pulling down the hill. And that equals the mass of both times A. I think that's going to give me acceleration equals m1g minus m2g. Parallel two lines is going to be sine of 56 degrees, all divided by m1 plus m2, which is going to be 10 times 9.8 minus 4 times 9.8 times sine 56 divided by 14, 10 plus 4. Do you get an acceleration of 4.68? Find the tension in the rope. You could use M2 to find the tension. I'm going to use M1 because it's way less yucky. Even though tension is losing in M1, it's going to be M1G minus tension equals M1A. And I'm just going to plus this to this side and minus that to that side. When I do that, I'm going to get tension equals M1G minus M1A is 10 times 9.8 minus 10 times 4.68. It's going to be 98 minus 46 is going to be 58 minus 52, 51.2. It's a 10 times table. I can do that in my head, even if it's decimals. I better be able to. Units? Newtons? Okay. What would the minimum magnitude of the force of friction on M2 have to be in order to keep this entire system stationary? Ah. Key word here. Because what this is really telling me is my acceleration is going to be 0. Now, I would still have M1G pulling down. I would still have my tensions cancel, and because I don't have much room to write, I'm not going to show that step. I would still have minus M2G parallel, but now I would also have minus the force of friction, because that's down the hill. In fact, I would argue that I could plus the force of friction over to this side, because there's a 0 there. In fact, I think I would even say this. Friction has to cancel out those two. Well, has to cancel out gravity of M1, and M2G parallel is helping friction. I think I'm going to get this. 10 times 9.8 minus 4 times 9.8 sine of 56. That equals friction. And we're going to get, Zach is pumping his fist in triumph. .5 newtons. Now, how else could I throw a twist on this? What if instead of saying, what's the minimum magnitude of the force of friction, what if I said, what does mu have to be? Could you find that? Sure. Friction is what times what? I don't know the normal force. Oh, but look. I know another force the same size as the normal force. You'd have mu m 2g perpendicular. Oh, perpendicular is cos. Oh, I guess I would divide by m2g cos. I'd have the mu by itself. I could find that too. How else could I? I guess that's about all I could ask. Why did I say minimum magnitude of the force of friction? It's only, yeah, it could be more. Could be more, but minimum. In terms of part marks for that one, well, for the first part, for the acceleration, if I saw that, that got you 1 mark. Half mark for that, half mark for the answer. 1 mark for that, 1 mark for the answer. And apparently here I went all or nothing, 65.5 newtons. I'd probably give you a half mark if I saw this right here, and then a half mark for the answer. Can you give yourself a nice clear score out of 17, please? So officially we are done the unit. However, I will say questions. So I had somebody who just wanted to throw a question from way back on inclined planes. I don't mind. Which one, sir?
Number 9.
Number 9.
10 kilogram mass slides over around 10 degrees. Starts at
I think I like number 9. I think I like number. I like most of number 9. I like you'll see a question similar to this. I can't remember. On one of my tests, maybe I'm not asking for the coefficient of friction. I'm asking for something, but the setup is going to be completely identical. So let's look at this. This is from lesson 6, number 9. If you don't have it, you can just kind of follow along, and I'm going to copy and paste it down here because it's just easier to do it that way. Lesson 6. Now, the nice thing is, I'm not going to teach you anything new here if I've done my job right. Hopefully, somewhere along the way, you'll go, oh, okay, I can see what to do the rest of it. I do like this tug of war. There are other approaches to solving forces, but the tug of war approach really bails us out of a lot, and even most of your first year stuff. Until you have changing masses, then you need calculus. So, a 10 kilogram mass slides up a ramp inclined at 10 degrees, not very steep, stops after 4.6 meters. If the mass was initially moving at 4 meters per second, find the coefficient of friction. I think I need to dulp. So, here's my ramp. Here's my mass. It's moving this way and it's going to come to a stop. What are the forces acting on this? Get the obvious one. Darn right. There's going to be friction. Which way is friction if this is moving up the ramp? That's going to be a twist. And yeah, I'll break these into mg perpendicular and mg parallel. Let's write a force equation. Who's winning? It's a trick question. Now it's moving up, but which way is it accelerating? Because it's slowing down. So who's winning? Friction and mg parallel. Here, I'm not going to have winner minus loser. I'm going to have winner plus winner. It's going to be mg parallel plus friction equals ma. That's step one. That's the key to solving this. mg parallel, Cole gave us our lovely mg 2 lines as sine. Nope, we're still got a ways to go. Friction is mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Mg perpendicular, which is going to be mg cos 10 degrees equals ma. Our ever astute Graydon says, hey, Mr. Dewick, I noticed something cancels. What are they asking me to find? Careful. Yeah, not the force. Mu. Well, by the way, what are the units for the coefficient of friction? What do I measure it in? Yeah, no units. It's a ratio. It's a unitless measurement. So don't put newtons. It's not a force. It's a ratio. In fact, it's defined as the normal force divided by mg, which is newtons divided by newtons. Your newtons would cancel. You have no units. So let's see here. I think I defined that wrong. It's defined as friction force divided by mg. Anyways, don't worry about it right now. Let's get the mu by itself. I can do that. I'm going to minus this over, Graydon, and then divide by those there. I think I'm going to have this. Mu equals a minus g sine 10 divided by g cos 10. Let's walk through our quick checklist then. Do I know G? I know cos. Do I know G? Do I know A? No. Even though this question said find mu, I think what I'm really going to have to find first is, can I? Well, now they're talking about finding acceleration, and I don't think that I'm going to find the acceleration using forces, because I've already written my force equation. I think I'm going to find the acceleration using the other stuff that they gave me, the fact that they said this and this. I think now I'm going to go back to Unit 1. I'm going to say, well, D is 4.06. A is, I don't know. Oh. VI, it says, is 4, yes? V final is 0. Is that enough to find an acceleration? Emily is nodding her head. Emily is correct. Which equation? Get the A by itself. You're right, it's the right equation. Get the A by itself in your head. Okay. Oh, 2D, Mr. Duke. Is that okay so far? Now, because you're in Unit 1 and you're slowing down, when you solve this, you are going to get a negative answer. Ditch the sign, because over here, we defined negative to be positive, so don't put a negative right there. That's all. So take it the rest away yourself. I would consider that a fair question. I'd consider that a B plus A minus level, but I would be okay putting 1 like that on the written. Absolutely. Absolutely. Okay. Any others? Lesson 8, question 2. I like question 2. I like question 2. I like question 2. Number 2 is a nice question. And I erased my diagram because I'm going to do a slightly better diagram. So it says the mower is pulled. You know what? Because I know I'm going to need lots of room. I'm going to do number 2, the dolp up here, if that's okay, and the work down here. And heck, let's even really go high-tech, Mr. Dewick. Draw. There's my lawnmower. And we're pulling, yoink, 45 degrees, which is about there. What are the forces acting on this lawnmower? Get the obvious ones. Darn right, gravity. Straight down, thankfully. I like that. What else? Oh, it says pushed with 500. Yeah, number 2, pulled, right? I'm doing number 2. Pulled with 300 newtons of force along its handle. Okay, which is at 40 degrees. Okay. mg, this is 300 newtons. Here's our applied force. What other forces are acting on here? Friction, it says, yes? Brett, you asked me this, yes? Or no? Who asked me this one? Okay. Friction, yeah? And normal force. Now, if I asked you to draw the free body diagram for this, I would look for this. Why did I draw the normal force so small, so much smaller than gravity? Is the normal force equal to mg? So you know. Why? Yeah, I need to realize that there's going to be, and I called this a horizontal, Fx, and a vertical component, and I said the angle was 45 because I was reading number 1. It's 40 degrees. Okay? The normal force is going to be on my diagram, but it's not going to be long. It's going to be short. In fact, let's see, it wants me to find the normal force. I'll call that part A. I think the normal force, I think mg is going to be the same size as the normal force plus Fy. I think the two verticals cancel out the big, the two upwards cancel out the big downwards. Is that okay so far, Brett? Which I think means normal force is going to be mg minus Fy. And I think if we do the trig, we're going to find Fy equals sine again. It's going to be mg minus the applied force, 300 sine 40. Let's see what I get here. Mg, m, 50, covering it up. 50 times 9.8 minus 300 sine 40. 297.1637, 297. B. What's the second thing it wants me to find, Brett? Friction force. Friction is mu times the normal force, which conveniently I just found. Normally I say, I don't know the normal force. I do know the normal force. It's 297.1. It's that. So mu is 0.1, the question says, times 297. You know what? I can do that in my head. It's going to be 29.7 newtons, because multiplying by 0.1, same as dividing by 10. I've learned that over the years. C, find the acceleration. Okay, who's winning? Which way is it accelerating? I think it's going to be rolling or sliding to the right, to the right. So who's winning? Fx. It's going to be winner minus friction equals ma. By the way, what if this wasn't moving at all? What if I told you that we were pulling on this lawnmower and it was stuck? What would A be? 0, in which case Fx equals friction, and I could probably work my way backwards up these equations, and I could find a coefficient of friction, or I could find all sorts of stuff. But let's keep going here. I think A is going to be Fx, which I think is 300 cos 40, minus friction, which was 29.7. divided by the mass, which was 50. That should get you the acceleration of hopefully 4 meters per second squared. Any others? Can you all get out the great big unit review, the ultimate vector dynamics assignment? This one here, please. There's always a stapler up there, and there's always a stapler back there where you hand stuff in, or there should be, unless kids move stuff around. So if you look at the ultimate vector dynamics review, this is due on Monday, the day of your test. I like number 3. Number 6 is a nice question. I like number 6. I like that, yeah. 7. 9. 10. 10. 10. 13. Oh, sure, 14. 15. What I'm looking for is, I know on your test there's a couple of questions where I go backwards, where I give you the acceleration and I say work your way backwards to find a missing mass or mu or one of the missing things. So I'm trying to find kind of ones like that. I've given you a few of them already. I'm kind of assuming that you're okay with the going forwards. 26. You know what? Although it says 38 is a scholarship question, I would not consider 38 to be a scholarship question anymore. Key concept with 38 is, if it's moving at a constant speed, what does that tell you? So now it's going to be winner minus loser equals 0, which actually I think gives you an easier equation. And they're wanting you to find mu, which is very similar to what we just did for Brett, except it's instead of a person on a lawnmower at an angle, it's a ramp at an angle. Okay, different idea, but the same kind of concept. Certainly A is totally fair game. Oh, and you know what? B, all you're doing is you're moving some of the mass. You just got to redo the masses. So if 0.15 kilograms of mass is transferred from the box, that means you would minus 0.15 kilograms from that mass, and you would add 0.15 kilograms to that mass and find the acceleration. You know what? That 38 is totally a fair game question. I don't think I give you the two separate parts like that for 12 marks, but to me, I don't know why that would have been a scholarship, or maybe that was considered an easy scholarship that year. In fact, 39 to me is fair game too. I've done stuff like that with you. Okay. So that gives you some hints. Any other questions you want me to go over? Number 2 on the review?
I think I did it wrong.
Have you looked at my online answer key yet?
No, I just did it.
Not that I don't want to help you, but if I bring it up here, you'll probably figure it out yourself and you'll have learned it better. Ultimate review answer key. Number 2 should be right near the top. So I drew a free body diagram. I said gravity, normal force, friction is what's slowing. And friction's the only force. That's why he's slowing down. So friction equals ma, mu Fm equals ma, mu mg equals ma. The m's cancel. I think mu equals a over g. Level ground. This was nice. Is that okay? Oh, and by the way, what are we on? What surface, according to this question, are we on? What type of a surface? Snow. They try and give you reasonable answers. I would have crossed out D right away. There's no way snow has a coefficient of friction. Tires on rubber have a coefficient of friction of about 0.5. There's no way snow has that. In fact, I probably would have crossed out in my mind C. I would have targeted A and B right away and said it's got to be one of those. If I was in a pinch and having to guess because I'd run out of time or something like that, I would have said, it's not D, it's not C. Ice is around 0.01, 0.005. If snow is around 0.1, point-ish. I have a bit of an instinct for how slippery stuff is. Any other questions? Okay, give me a second here. Right click. Stop.